What I'd like to do here is look at the second example of the last video and discuss why, when we're zooming out, we only have to look at that leading term. It's a very vague thing to do. It is correct, but when you get to calculus, they're going to ask for a precise algebraic way of looking at it, and that's something we're going to want to do here. So I just want to do some algebra and see what's going on. Now, every time we have a polynomial, it has a highest power. What I want to do is factor out that highest power and see what I can say about what's going on. So let's factor out the highest power. So x to the 6, like this. Now, minus 7x to the 6 divided by x to the 6 is just minus 7. That's good. Minus 21x to the 5th divided by x to the 6th is minus 21 over x. 35x to the 4th divided by x to the 6th is plus 35x squared, and so on. I'm going to get plus 105 x over x to the 3rd minus 28 over x to the 4th minus 84 over x to the 5th. Now, why would we do that? Because now, when x gets really, really large, we can see what's going on. And let's look at this piece right here. Put this one in green just to see what's going on. If x is really, really large, this is a fraction where the top is 21 and the bottom is really, really tiny. A fraction where the bottom is as big as possible, just getting bigger all the time, and the top is just 21, this is a fraction that's getting very close to 0. This one is very similar, except the bottom is getting smaller even faster. This is also getting close to 0. This one also is getting close to 0. This one also is getting close to 0. This one also is getting close to 0. Now the minus 7 just stays minus 7. And what's going to happen with this whole thing, right? The x to the 6th is just behaving like x to the 6th. The stuff inside the parentheses is getting very, very close to minus 7. And so what we get is the leading term. Right? We can do this every time we have a polynomial. We can just factor out the highest power. We can see inside the parentheses that everything goes away or gets really, really tiny except that leading coefficient. So this is how come when you look at the end behavior of a polynomial, you just have to look at the leading term, because you can factor out the leading power and just describe what's going on exactly the way we did here.